one more type of problem you should be aware of is what happens if I have a couple of missing terms, but I'm told that this is going to be an arithmetic sequence. Okay, so the way to do a problem like this one, if you have a couple of missing terms, is you can realize, well, if it's arithmetic, there has to be some D value, common difference, that I would add to get from term to term. Okay, so add D, etc. Okay, so what I could do is do 4, and then I'm adding 4 common differences to get from term to term to term. So 4 plus 4D would be 10, so 4D would be 6, and then of course D would be 1.5. So I could add, 4 plus 1.5 to get the next term. What's that going to be? 5.5. You get the idea, and then I could actually fill in the terms once I have that common difference. Okay, let's say I had the same problem and it was geometric. Okay, then instead of adding a common difference, what I would do in this case is multiply by a common ratio, but I would do that 4 times. So I multiply by the common ratio, multiply the common ratio, multiply the common ratio, multiply the common ratio. That's going to look like 4r to the 4th, right? So 4 times r 4 times equals 10. I get r to the 4th equals 10 fourths. And what I can go ahead and do is take the 4th root of that. Actually, let's simplify it first to 5 halves. And then, so then I get r would be equal to 5 halves to the 4th root. Now here's the thing, and I probably should have put this in the quiz last week, that it really can be plus or minus for this answer if you think about it, because if I multiplied by a negative number, it would just swap terms. So 4 times a negative number, it'll be negative here, positive here, negative here, positive here. So really either the plus or minus of that 4th root of 5 halves, which you could do on the calculator, would work to generate the ratio that you need for multiplying term to term to term. And I'd be okay if you just wanted to use the decimal approximation for that.